Let's see, 414. This is kind of a tedious problem, but I think it's interesting, so I wanna go through it. Suppose you reflect the plane across the line y equals 2x, and then you rotate it 10 degrees counterclockwise. So you're doing a reflection and a rotation together. And we've seen that if you do these together, it's equivalent to some other just single reflection. So it says this is equivalent to reflecting across the line y equals mx. Find the m to 3 decimal places. Okay, setting this up is going to be a little bit, it's going to be a bit tedious. Let's see, for the y equals 2x, we'll plug 2 into here. Let's call this A. In our A matrix, we've seen this one before. It's negative 0.6, 0.8, 0.8, 0.6. All right, and then the rotation matrix of 10 degrees, I'm going to call that B. And so this is going to be cosine of 10 degrees, negative sine 10 degrees, sine 10 degrees, cosine 10 degrees. And I could get Octave to work that out, but I'm just going to use a calculator because that's going to be quicker. So cosine of 10 degrees, I'm going to do this to 4 decimal places at least. Let's see, 98.48. And then sine of 10 degrees is 0.1736. Got to make that one negative. All right, so I've got those, and let's put those, well, let's see. We're supposed to reflect across the line here, and then rotate it 10 degrees. So that means if we were applying this to some vector, we do the reflection first, so we do A there, and then we do the rotation after that. So BA is the matrix we want. That's going to be a matrix of reflection. So let's go to Desmos, not Desmos, let's go to Octave. Let's see, I've already got my A matrix in there. B, I'm just going to put in 0.9848, negative 0.1736, 0.1736, 0.9848. All right, so we get that. So if we do B times A, we get this. So our reflection matrix then is, I'm going to move this up. Our reflection matrix is negative 7298. And same thing down here. Put positive. And then 6837 for the others. All right, so that is our reflection matrix. And if they just told us to find the reflection matrix, we'd be done. Unfortunately, it says figure out what the M is for this. This is the reflection across or over y equals mx. So to solve for this, what we need to do is come back up here and look at 2m over 1 plus m squared is equal to this. And then m squared minus 1 over 1 plus m squared is equal to that. So we've got a couple of equations to solve, and both of them are quadratic. So let's see. 2m, let me get a better color. 2m over 1 plus m squared is equal to 0.6837. And then m squared minus 1 over 1 plus m squared, that's going to be equal to 0.7298. Now let's make sure I've got the correct sign there. I'm using this, which is positive, and that's this entry, which is m squared minus 1. Okay, so what we've got to do is solve these two equations. Now, this is going to give us, if I multiply this out, this is going to give me 2m is 0.6837 plus 0.6837 m squared. This over here is going to give me m squared minus 1 equals 0.7298 times 1 plus m squared. Tell you what, let's go ahead and distribute that out. So we get 0.7298 times 1 plus 0.7298 times m squared. So we've got to solve this equation and this equation. Now both of these are going to have two solutions. I'll tell you what let's do. Let's scribble this out. We're just going to use the rest of the space on this page to solve this. Okay, this is going to give me, if I move the 2 over, I get 0.6837 m squared minus 0.2m plus 0.6837. And this one gives me, well, let's just solve this one first. This is equal to 0. So we get m is equal to minus b got somehow a decimal creeped in there that's not supposed to be there. So I get 2 plus or minus the square root of b squared minus 4 times a times c. Notice a and c here are the same thing. So 0.6837 squared over 2 times 0.6837. Okay, so I've got to solve this. I don't have the calculator I would prefer to use for this. So I'm just going to type it all in here. 2 plus square root of 4 minus 4 times 0.6837 squared, all over 2 times 0.6837. Okay, when I put that in there, it gives me 2.53 and a bunch of zeros. And that's just with the plus. So I need to change the plus there to a minus, and that'll give us the other solution. So I'll change that to a minus. Eventually I can get back to it. If I put in a minus, it gives me 0.395. Okay, so one of those is the solution. To figure out which one, we've got to come to this other equation over here and solve it. So this guy, I'm going to move the 1 over there, so I get m squared is 1.7298 plus 0.7298 m squared. I'll subtract this off of both sides. So 1 minus 0.7298 is 0.2702. So 0.2702 m squared is 1.7298. So m squared is 1.7298 divided by 0.2702. That gives me 6.401925. So m is going to be plus or minus the square root of that. And my calculator says the square root of that is 2.530. So we got two solutions over here and two solutions over here. The common solution between the two of them is the correct one. So that's 2.530. And that's it. And I think that's enough for this problem. Let's don't worry about doing the next example. The next example, 4.15, is to do the same thing but do the rotation first. If we wanted to do that, all we need to do would be come back up here, and instead of doing BA, we do the same thing with AB. But I think that's enough of this for now, so we'll stop here.